In this video, we're going to take a look at a special kind of sequence called a geometric sequence. So a geometric sequence is a sequence in which from one term to the next, you see that you are multiplying by the same value each time. So if you were to look at the pattern there, it would be, hey, I'm multiplying by some common ratio, is what we're going to call that, to get from one term to the next. So the pattern there is multiplication. A is the value of the first term, R is that thing we are multiplying by each time, and then N would be the value of the, N would be the number term I'm looking for, and A of N would be the value of that term. Notice how the formula here is exponential. So if I have a first term of 3 and a common ratio of 2, that means I'm multiplying by 2 every time. What would the first 5 terms of the sequence be? Now, I don't actually need to use this formula to figure those things out. If I have A and R, it's often easier to just list those things out. So the first term would be 3. The second term would be, if I'm multiplying by 2, my common ratio is 2, my second term would be 6. And then I would get 12, and then 24, and then 48, right? So if we're multiplying by 2 every time, those would be the values of my first 5 terms. Now, the nth term, that means, okay, use this formula to write the general form here for the nth term. So the nth term, A of N, would be the first term, 3, times the common ratio, 2, to the n minus 1 power. That would give us the value of the nth term. So if I actually wanted to find the 4th term by using this formula, I know that it's going to be 24, but I could plug in 4 for n, and it would say 3 times 2 to the third. 2 to the third is 8, times 3 is 24. Okay, so I could use this formula to find any term that I want for this sequence. I will caution you here, make sure you don't multiply these together before you do the exponent. If you're using the formula, make sure you do 2 to the exponent and then multiply by 3. Same setup here. I have A as 2 and R as negative 5. Find the first 5 terms and the nth term. So the first term is 2, and then we are multiplying by negative 5, so my next term is going to be negative 10, and then positive 50, and then negative 250, and then positive 1250. And notice it's alternating in sign there because R is a negative number. The nth term, AN, is going to be the first term, 2, times the common ratio, negative 5, to the n minus 1 power. Find the 8th term of a geometric sequence that starts 5, 15, 45. So again, I know that it's geometric, so I know that it's going to have that common ratio every time. I just got to figure out what that is. So my value of my 8th term is going to be the first term, which is 5, times the common ratio, which would be 3, multiplying by 3 each time, to the 8 minus 1 power. So that's 5 times 3 to the 7th, 5 times 3 to the 7th, which you can use a calculator to figure out, which is 10,935. Okay, and then the last question here, I know the 3rd term, I know the 6th term, I want to find the 5th term. So in order to do that, I need to figure out the values of A and R. So there's going to be a little bit of work here, but what I'm going to do is I'm going to use this formula, AN equals AR to the n minus 1, and I'm going to write this formula for both my 3rd term and my 6th term. So the value of the 3rd term is 63 over 4. That happens if I do A times R to the 3rd term, 3 minus 1. That's going to give me 63 over 4. So that tells me that AR squared is equal to 63 fourths. The other one is my 6th term, so if I plug in 6 for n, I'm supposed to get 1701. So that would tell me that AR to the 6 minus 1 is going to equal 1701 over 32. So AR to the fifth equals 1701 over 32. So what we have here is a system of equations. However, it's a little bit different than probably most systems that you've seen. So we actually are multiplying A and R and not adding those. So how do I handle a system of equations where the variables are being multiplied? I simply just need to divide these two functions. So what I'm going to do is I'm going to take the one with the higher exponent, and I'm going to divide by the other one. So I'm going to take this function and divide by AR squared equals 63 over 4. I'm just going to divide everything straight down. So my A's would cancel out. R to the fifth over R squared, that's going to give me R to the third. And if I divide these, if you're dividing fractions here, just divide the numerators and divide the denominators. So 1701 divided by 63 is 27. And 32 divided by 4 is 8. So that gives me that R cubed is 27/8. So if I take the cube root of this, I'm going to get that R is equal to 3 halves. Okay. So now we know R. We can find A. I'm going to use this formula here. So A is going to be 3 halves squared. So A times 3 halves squared is equal to 63 fourths. And I'm looking for A. So if I square 3 halves, I'm going to get A times 9 fourths is equal to 63 fourths. So what times 9 fourths equals 63 fourths? That means I need to multiply by 7, right? So A is 7. So now I know the value of A and R. I can use those to then find the value of the fifth term. So I want to find A of 5. I now know that A is 7. I know that R is 3 halves. And we're going to plug in 5 minus 1 as my exponent. So that gives us 7 times 3 halves to the fourth. I'm going to use a calculator for that. That gives me 567 over 16. Okay, so again, you may have to use a system of equations to figure out the values of A and R. Once you have those, you can find the value of any term in that sequence.